Let's see this concept called as expectation or mean. The initial when they invented this concept for the first time, they did it so that when they conduct an experiment, they wanted to know which value is most probably the one to come out. See, what I mean to say is, let us say you have an experiment and you are conducting it, random experiment, and now even before the experiment is conducted, if you want to guess which value is having the highest possibility to come out, in order to know that, they have invented this concept. But then later what happened is, in many of the cases this concept will not be so much useful to guess it, because in most of the cases all the outputs will be equally likely. But anyway, knowing this concept will be useful in some of the experiments for sure. Okay, now what I'll do is, I'll take an experiment and I'll explain you this concept. Later I'll discuss about the exact formula and how to apply it in the case of discrete and in the case of continuous random variables. First I'll take an example on discrete example. Okay, discrete random variable. Assume that x is a discrete random variable which denotes the number of heads that might come up while flipping two coins. Okay, so what are the various possibilities? So one is, I might get x equal to 0, which means I might not get any head. So what is the probability that x will take a value 0? The probability that x will take a 0, or I'll do it in another way. Let me write it in a table. Okay, now this is the random variable x, and it is the probability that x will take some value. Now when I am flipping two coins, what are the various possible values that I might get for x? So when I flip two coins, both the coins might get a head, or one of them might get a head, or 0, which means x might take 0, or x might take 1, or x might take 2, right? So when I flip two coins, I might not get any head at all, or when I flip two coins, I might get only one head, or when I flip two coins, I might get two heads, right? Now how does this event look like? This is nothing but the event of getting two tails. This is nothing but the two events, getting first tail and head, or first head and then tail. This is nothing but getting head and head, right? Therefore, what is the probability of each one? The probability of getting 0 is nothing but 1 by 4, and the probability of getting this one is nothing but 2 by 4, or it is 1 by 2, and the probability of getting a 2 is 1 by 4. I hope you know how I'm writing this, isn't it? In the sample space we have totally 4 elements, and each element can take 1 by 4, and since this is taking 2 elements, it is going to have 2 by 4 as the probability. Now if I multiply them and add them, right, which means if I apply this sigma I into probability that x will take a value I, if I multiply this value with this value and I add them all, right, for all I such that p of I is greater than 0, which means for all values, if you take this, then that is called as expectation. So in this case, what is the expectation of this discrete random variable is 0 into 1 by 4 plus 1 into 2 by 4 plus 2 into 1 by 4, right? Now just check this. It is nothing but 0. This is 2 by 4. This is again 2 by 4, isn't it? 2 by 4 plus 2 by 4, which is nothing but 1. Alright, so what does this one show? This one is showing that when you are the expectation of this random variable x is going to be 1, which means even before conducting the experiment we can guess that there are more chances that you might get a value of 1 if you conduct this experiment. And in this case it is of course true, isn't it? If you check it, the probability of getting a 1 is high compared to probability of getting a 0 or probability of getting a 2, isn't it? Here it is 1 by 4, here it is 1 by 4, here it is 2 by 4. That is why we got the expectation 1. So that is why it is useful. So what does expectation of a random variable give? What is the maximum probability that it will get some value, or what is the, if you conduct the experiment what is the value that you might expect, or what is the value that might come up with a higher probability. It is true in some cases, but in some other cases, even though we get some value, it is not true that that value of that, the probability of that value is high. Therefore, even though it is useful in some experiments, it might not be useful in some other experiments. Let's see this. Let us assume that capital X is a random variable, discrete random variable, which denotes the number when I roll a dice. Okay, if I roll a die, then what are the numbers that might come up? The numbers that might come up is 1 or 2 or 3 or 4 or 5 or 6. What is the probability that X will get these numbers? The probability is 1 by 6, 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 1 by 6. Then what is the expectation of X? It is also represented like this, expectation of X, right? Expectation of X is equal to sigma I into P of X equal to I, which means I have to multiply these corresponding values and I have to add them up. Now what is it? It is 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by 6. I think you understood how I am writing this. When I multiply these two, for all of them the denominator is 6. That is why I am writing 6 there. Now this is nothing but sum of first 6 natural numbers, right? So what is the formula? 6 into 6 plus 1 by 2 into 6. So it is going to be roughly 3.5. Now it is saying that when you roll a die, the number that will come up will be close to 3.5, which means it will be either 3 or 4 with high probability. But then if you observe this one, all of them are equally probable. That is why we cannot say that exactly. So people have stopped saying it. Got it? So expectation has nothing to do with what comes up on the in the experiment in most of the cases. In some of the cases it will give you what is the highly likely event that will come up. Otherwise, in most of the cases it will not give you. It is actually depending on the experiment as well. Got it? So what I'll do is, so what is important for gate here is, once you know how to find out the expectation this way, there are two types of random variables. One is discrete random variables and other is continuous random variables. So what I'll do is, in exam they will ask you what is the expectation of this, what is the expectation of that, like that. Okay, so what I'll do is, I'll derive for every case what is the expectation of that random variable. You just see the derivation, don't by heart it, but if you want to remember, just remember the final answer, right? So in every case I'll give you what is the expectation of Bernoulli random variable, binomial random variable, or normal random variable. I'll give you what is the expectation of each one. Don't by heart them, but then by heart the final answer. The proof is not required, but still, just for the sake of understanding, I'll give you the proof to understand how they are actually derived. So once you understand all the derivations, in case if they ask you about a completely new random variable, if they define it in the exam and if they ask you expectation, you will be able to do that. But proofs are not required, just the values are required. You by heart the values, just see the proof. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. after taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.